Next section is called inverse transforms and their derivative. So we'll start with the transforms first. And you could see, like, just going back from last section, if we did the transformation of 1, we got 1 over s, so the inverse of 1 over s is 1. Same thing, the transform of t, 1 over s squared, inverse of, if you didn't know, I'm looking at these two columns. So the inverse of 1 over s squared is t. And the last one they have here as an example is if we did the transform of e to the negative 3t to 1 over s plus 3. And so if you do the inverse of 1 over s plus 3, you get e to the negative 3t. So again, these are just the properties you should know, and use them as you're going along. You'll see when we get to derivatives and solving, it's helpful. Okay, so just to do a couple examples that'll give you a little trouble, like let's say you have the inverse of 1 over s to the 5th. So if you go back, right, go to this here, we know it's going to be t to the 4th, but it doesn't have that 4 factorial. So we could include that in there if I just do like 1 over 4 factorial times the inverse 4 factorial over s to the 5th, right? So the reason why I did that was so that I'm really multiplying by 1, but I want to know what my answer will be. So here now I'll get 1 over 24, and then I know it'll be a t to the 4th. Just going backwards with that letter B in the rules. Okay. Very similarly, what if we want to do inverse of 1 over s squared plus 7? Well, I know it looks close to, like a sign, because you have that s squared, and we could always say square root of 7 would be our k. So that's good. So, but I want to do the same step here where I multiply by a factor of 1 with that root 7 over root 7, but I just bring one of the root 7s in, and then that way we would get 1 over square root of 7, and then this one would be a sine of root 7t. Okay. All right, and a couple more things. If you have a fraction that can be broken up, then break it up, right? So I could do negative 2s over s squared plus 4, right? We could do the inverse of that one first, plus the inverse of the 6 over s squared plus 4. Now a couple things here, right? If you notice up top, right, these are going to be the sine and the cosine. So for this first one, that's going to be a cosine. Let's take out that negative 2. And you can see here k is going to be 2. On this one, I still want it to be, use that sine function. So let's take out a 3, and then that way I will have 2 over s squared plus 4. And then I have it in the form I want, and I'm left with negative 2 cosine 2t and plus 3 sine 2t. All right. And then at times, right, and I'm going to use this in a couple examples, this next one that we have, you'll have to do some partial fractions. Okay, so if I give you something like this, all right, what's going to happen is you want to break this up with all your linear factors that you have here. Okay, so the linear factors are going to be a over s minus 1 plus b over s minus 2 plus c over s plus 4. Okay, now common denominator, right? S minus 1, s plus 4 plus b, s minus 1, s plus 4, and the last one plus c, and that's going to be s minus 1, s minus 2. Okay, and remember, this will equal the numerator, so s squared plus 6s plus 9. So if we pick s to be 1, okay, so remember, just plug in everywhere, and I'm trying to cancel out. You can see if I plug in s to be 1 there, that cancels out the b and the c, and I'm just left with let's see, so I get 16 equals negative 5a, so I got a to be 16, negative 16 fifths. If I make s to be 2, I could solve for b, so I would have 25 equals 6b. b is going to be 25 over 6. And if s is negative 4, I get 1 equals 30c, so c is going to be 1/30th. Negative, right? Yeah, it'll be negative 1, right? Yeah. Okay. Now we can plug that back in here, right? So you'll have the inverse of negative 16 fifths over the s minus 1 plus 25 fifths over s minus 2 plus negative 1/30th s plus 4. Now if you do the inverse, just use your rules. Negative 16 fifths e to the t plus 25 sixths e to the 2t and minus 1/30th e to the negative 4t. Okay. So again, sometimes you got to do some algebra there to get to the final answer. So now we're going to do transformations or transforms of derivatives. So basically I'm going to go into solving these differentials using these Laplace transformations. So if you have Laplace of a derivative, right, f prime of t, okay, that's going to equal s f of s minus the initial value that you have. Second derivative, right, so it's going to be s squared f of s minus s initial value, and then the derivative's initial value. Okay. Third derivative, same idea. Start with s cubed. You have capital F of s minus s squared f prime of s. Sorry, not prime. What am I doing? Just f of s, and then minus s, the derivative of 0, and then always ending with the previous initial value derivative. Okay, so that pattern continues. how do we use this is the main thing. And a couple things that you want to do is, it doesn't always have to be an f. Like if we're doing these, you see on the next problem they use y of 0, but it's the same idea. Okay, so if I want to, and it works for an initial value problem, so you're using Laplace to solve initial value problem. So here, if I give you this first order, which is pretty straightforward, the way it works is you apply Laplace, right, to everything. Okay, so I'm going to go back up and use that derivative. Now the function is y of, so I'm going to just change a couple things here to be y's. So I have the s, and I have the capital now y of s. I'm making it capital, right, because it's a transformation. And then minus that lowercase or initial value y of 0, and then plus 3 times y of s for the function y. Any time you do the Laplace of a y, oops, it's just going to be like capital Y of s. Okay, and then that equals, now we go back to our rule for the sine function, so 13 times 2 over s squared plus 4, just like that. All right, so let's simplify this a bit. All right, so here you're going to have s y of s minus 6 plus 3 y of s, and that equals 26 over s squared plus 4. All right, so combine like terms, so you have s plus 3 y of s, and I'm going to bring that 6 to the other side. Okay, so I have plus 6. Solve for y of s. Okay, again, same idea. You're going to have to do this step a lot, common denominator. So here we'll have 26 plus 6 times 3, sorry, that's wrong. 6 times s squared plus 4 all over s squared plus 4 and s plus 3. So that gives us 6s squared plus 50 over s squared plus 4, and then s plus 3. So this is the whole idea here. Once you get down to this step, right, now you're doing the inverse of this. Okay, you're doing the inverse of this and the inverse of this whole thing, right? So what we want to do is break this into another partial fraction. I have to break that into a partial fraction as well, and then I could do the inverse. Anytime you go from, okay, anytime you're looking at that, you're just going to go back to the function itself, y of t. All right, but here I have to do partial fraction again. And let me go over this, all right? So because we have the s squared plus 4, which is not linear and you can't break it up, and then a linear, it's a little bit different. So with the linear, let's just keep it the same. Put a constant over that linear factor. Now, for the other one, you have to compensate. So because it's squared, think of it doing one less degree, so you're going to have a constant b times s plus another constant c over s squared plus 4. Now everything else is done the same, so you're going to still go a s squared plus 4 plus bs bs plus c times the s plus 3, right? And we know that's going to equal the 6s squared plus 50. Okay. Now, when you solve this, you do. I mean, this is tough because you can only really find a first. We'll do that quickly too as well. But you're going to have to distribute it out. So we'll get bs squared plus 3bs plus cs plus 3c. Okay. Okay, and then I like to group them. A plus b s squared, and then plus 3b plus c s, and plus 4a plus 3c. All right, and then you could kind of see that the a plus b is going to equal to 6 because of the s squared. The 4a plus 3c is going to equal to 50, and your middle one is equal to 0. So you actually have the 3 functions, 3 unknowns. Again, some algebra. And a quick way to solve, though, for one of these, I mean, you could do substitution method, substitute, and plug in, but to find a, if we just made s negative 3, and you could plug it into this top part, you would wind up getting 104 on the one side, right? 104 equals 13a, so a is 8. And then you could use that to find the other values. And b, if a is 8, then b is negative 2. And c would have to be positive 6. Okay. Now, once you do all that, right? So we got a, b, and c. I'm going to plug a, b, and c back into here, right? So I have that y of s is equal to, I got 8 over s plus 3 minus the 2s over plus 6 over that s squared plus 4. Okay? Now, when you do the inverse, so you're going back, right? We want to go backwards. And we could actually, let's break this up to 2s s squared plus 4 plus the 6 s squared plus 4. And these last two should look familiar. So now when I do the inverse of the whole thing, use your rules. And we go back with the lowercase y of t equal to 8e to the negative 3t minus 2. This is our cosine from that last problem we had earlier, right? Cosine 2t. And then plus 3 sine 2t. And there is your function. So you could see, I mean, I know it's a lot of work, but it gives you everything and you don't have to worry about those initial values you're using right from the start. Somewhat easier, I don't know, it's up to you guys on what you think is easier. When you're on a test, if you're using another method to solve, that's fine as well. But this is supposed to be a little easier, but it's new, it's brand new, so it's not as easy yet. Okay, next one I want to do is one more problem with this solving using Laplace and the derivative. All right, so again, right from the start, okay, you are going to apply Laplace to both sides. Okay, and then that's going to give us, just going back up to the top, you'll get y squared minus s y of 0 and minus y prime of 0, and then minus 3 parentheses sy, capital Y of s, minus y of 0, and then plus 2y of s, right? And then this equals 1 over s plus 4. Notice once you apply the Laplace transformation, you should have all s's in your function, right? So here, let's simplify a little bit. So we got minus y of 0 is 1, so it's minus s, and then minus 5, minus 3s y, capital Y of s, and then that'll be a plus 3 times 1, so plus 3, and then plus 2y of s equals 1 over s plus 4. Okay, let's group some things. So I have s squared minus 3s plus 2. Those are all the values in front, the coefficients in front of y of s. And then I have a minus s and a minus 2. And so let's do our work, right? Bring everything over. So I'll get 1 over s plus 4 plus s plus 2. Divide everything by that quadratic. Okay, and then you can see again, common denominator again, right? So that's going to give us 1 plus s plus 2, s plus 4 over s squared minus 3s plus 2, s plus 4. And here we get s squared plus 6s plus 9 over, I'm going to factor s minus 1, s minus 2, s plus 4. Okay, now that is our y of s. If you notice, this was from the previous video, right? Or no, this video earlier where we broke it up by partial fractions and we wound up getting the negative 16/5 s minus 1 plus 25 over 6 s minus 2, and then minus 1 over 30 s plus 4. Okay, so that is your capital Y of s. Now if you take the inverse, right, take the inverse, let's do red. Okay, you're just going backwards. So now we would get lowercase y of t equals negative 16/5 e to the t plus 25/6 e to the 2t, and then minus 1/30 e to the negative 4t. And that is your final answer. So, tedious sometimes, lengthy sometimes, but sometimes it's a little bit easier in the sense that you're already including your initial values. So, again, if there are easier methods to use, I have no problem with you doing that and finding another answer, but I would like you guys to try this the best you can. All right, great.